Okay, this video is going to go over some of the benchmark questions. I think we're going to do all 12 days in one video, so we'll see how that goes. That being said, on your recording sheet, because I have a hard time reading 2 and 3, on a lot of them are going to be flipped. It's not going to matter. For this example, for number 3, you would have A, B, C, and D on the number line. And for number 2, you're circling numbers on the card, so I don't think you're going to get confused on what's supposed to be what, but just as a heads up, a lot of those are flipped. That being said, this is what you turn in on the day of test. On the day of test, remember, if it's completed, you get 5 points on your test. If it's signed, you get 5 points on your test. So that means altogether you could earn up to 10 extra points on your benchmark test. In addition, because it's so close to Christmas and this is the 12 days of Mathmas, a turned in and completed review will also get you some hot chocolate to enjoy while you take your test. Being said, let's go ahead and get started. Number 1, or I guess partridge in a pear tree, numbers 1, 2, 3, and 4. So for number 1, we wanted to estimate the square roots and then put them in descending order. To estimate the square roots, we need our calculator. So we're going to Desmos and we're typing in, the first one was the square root of 80. The square root of 80 is about 8.9 if I round to the tenths. If I'm rounding to the tenths, that's 8.94. If I'm rounding to the hundredths, it'd be 8.94. And then the square root of 81 over 9 is next. So I go back to Desmos. Note here that the over 9 part is inside of the parentheses. So when I type divide by 9 and it's in the, sorry, not parentheses, in the square root, it gets to stay there. A lot of times we might have to type something like this, the square root of 81, and get out of the parentheses by clicking the left arrow, or the right arrow, I mean, and then divide by 9. That's not what we have. There is a difference there. So we are looking at the second row, not the third row, meaning our answer there is 3. And then the last one, the negative square root of 81. You guys should know the square root of 81 is 9, but this is negative, so negative 9. After that, you just wanted to put them in descending order. Descending means your biggest positive to your biggest negative. Well, we only had one negative. That's negative 9. So I'm going to put the negative square root of 81 last. And I'm done with that. And then my biggest positive was the square root of 80. And then the square root of 81/9 in the middle. Number 2, we want to know, how should the negative square root of 169 be classified on the real number system? We want to circle 3 correct answers. Well, in 8th grade, we know every number is real. To be irrational, I would need a square root equal to a decimal. And to be rational, I need the square root equal to a whole number. So I'm going to Desmos and I'm typing in the negative square root of 169. If you don't know that one off the top of your head. Button. I've got the negative square root of 169, which is negative 13. Because it's a whole number, we're going rational. And then we've got one more correct answer. I said whole, but I didn't really mean whole, because whole has to start at 0 and count up. And natural has to start at 1 and count up, which means whole and natural are 0, 1, 2, 3, 4, and so on. We're never going to get to negative 13. Integers are positive and negative whole numbers. So when I said square root that makes a whole number, I just mean something that doesn't have a decimal. So your 3 correct answers are real, rational, and number 3, draw a number line numbered from -4 to +4. Place each of the numbers on the number line. So I'm drawing a number line. There's one already on your papers for you. Here's my number line. And then I need -4, -3, -2, -1, 0, 1, 2, 3, and 4. And then we're estimating these numbers and then putting them on the number line. Letter A is pi, which we should know from 7th grade is about 3.14. There's also a pi button on Desmos. I'll put 3.14 to the right of 3, closer to 3 than 4 though. I'll call that A because it was letter A. Then letter B was the square root of 5. So I go to Desmos to type in the square root of 5. Desmos square root of 5 is about 2.236 and so on. I'll say that's 2.2 rounding to the nearest tenth. Rounding to the nearest tenth, that's about 2.2. So I need to be a little bit above the 2, but closer to 2 than 3. That's letter B. Letter C, negative square root of 9. The square root of 9 is 3, and there is a negative sign in front of it. So on negative 3 is where we're going to put the C. And then D, keeps red. The square root of 15, Desmos. I know it's going to be, no, right, Desmos. 16 is really close to 15, and the square root of 16 is 4, so the square root of 15 should be close to that. It's about 3.87 or 3.9 when I round to the nearest tenth. 3.9. So really close to the 4, but still between 3 and 4, and that's letter D. And then number 4, we wanted 3 examples of rational numbers. So 3 examples of rational numbers might be something, remember rational comes from the word ratio, which means fraction. So any fraction is going to be rational. We've got something like 6 over 7, 6 sevenths, or your decimals that stop, like negative 0.41, that stops, or decimals that repeat, like 6.6 repeating. Yep. Cool. Remember, that could also include numbers like negative 4, 0, positive 3. Your negative, positive whole numbers and 0 are also rational. You can write them like fractions by putting them over 1. 2 turtle doves. In order to do this page, you have to remember the steps to solving an equation. So the first step is to split, label, distribute, if you can. The second step is to sort and type. And then the third step is to divide by the coefficient. So, looking at the first one, then we will split, and I'll label the left side with B's and the right side with plain numbers because that's typically how you guys like that. And then I have to distribute if I can. Distribute means, do I have parentheses with a number on the outside? If that's a yes, then I can distribute. Distributing means that I'm going to distribute with multiplying the outside number to every inside piece. So we'll have 3 times b and 3 times negative 5. Well, 3 times b is just 3 b's. And 3 negative 5s, negative 5, negative 5, negative 5, or 3 times negative 5 is negative 15. I'm going to copy the other side down just so my math stays on one line and it's easy to follow. The second step is to sort the terms. We have b's on the left. So negative 3b stays on the left because it stays. I kept the same sign. I'm done with that term. Positive 12 doesn't have b's, but it's on the b side. So I have to switch it. Because we switch it, we change its sign. That's where negative comes from. Then 3b is on the plain number side, but it has a variable. So I switch it. Because I switch its sign. Now it's negative. The negative 15 is on the plain number side. It is a plain number. It stays. Because it stays, I keep its sign. Now I'm typing. The typing part is for the left side. I can't type in b's, but I can type in negative 3 minus 3. And negative 3 minus 3 is negative 6. So I have negative 6b. And then when I type in negative 12 minus 15, we get negative 27. The last step is to divide by the coefficient. So I'm dividing both sides by the coefficient. The coefficient is the number and sign touching the letter, the variable. B is the variable, so the coefficient is negative 6. I'm dividing both sides by negative 6. And I'm running out of room, but this leaves us with 1b equals negative 27 over negative 6. When you type it in is positive 4.5. So we have 1b equals 4.5. And that was for problem number 1. Problem number 2, this says x is in the problem because I forgot to type b instead. So I'll just change this to say solve for x. Same thing, I'm just solving for the variable. So we are going to start by splitting and labeling, and if we can, distribute. And we can distribute. We're distributing -5 to every term on the inside of the parentheses. -5 times x's is -5x's, -5x. -5 times 7 is just 7, -5 times, so -35. You can type that in on the computer. I'm going to copy down the other side so my equation is on one line and I'm organized. Second step is to sort. I have x terms on the left and plain numbers, constants on the right. -5x has an x, so it stays. Because it stays on the same side, it keeps the same sign, -5x on the left side with x's. -35 is not got x's, so it cannot stay on the x side, it has to switch. Because I'm switching it, I have to change its sign. So instead of -35, I have +35. 7x is on the constant side, but 7x is not a constant because it has a variable x. So I have to switch it. Because we're switching it, we have to change its sign. So instead of +7x, we have -7x. The -5 is a constant, so it stays on the constant side. Because it stays, we keep the sign the same, -5. This is where the typing comes in. On the right side, 35 minus 5 is just 30. On the left side, we have -5x's minus 7x's. You cannot type the x's, so we've got -5 minus 7. Well, -5 minus 7 is -12. That is the x side, so even though I couldn't type the x's in, I still have x's there. The last step is to divide by the coefficient. Dividing by the coefficient means on both sides I'm dividing. That's where the fraction bar comes in. And on both sides I'm dividing by the same thing. It has to be the number touching the x. The number and the sign touching x is -12. So we're dividing both sides by -12. That leaves us with 1x equals -2.5. This is just on the calculator. Looking at number 3, we have to solve for b. So I'm going to start by split, label, and if I can, distribute. Split, label, and I can't distribute, there's no parentheses. So I go straight into the next step, which is to sort my terms. 3/4 b on the b side, it stays. Because it stays, it keeps its sign. 3/4 b. +15 is on the b side, but it doesn't have b's, so +15 has to switch to the number side. Because it switches, I change its sign, so instead of +15, it's -15. 45 is on the plain number side, so it stays. Because it stays, I keep its sign. There was no sign, so I assumed it's positive. Then I have +1/4 b, which has b's, so it has to switch to the b side. Because I'm switching it, I switch its sign from positive to negative. So I have -1/4 b there. Now this is where I type. I want to show you guys how I would type 3/4 b minus 1/4 b. Remember, I can't type in the b's, but I can type in fraction, 3 in the numerator, 4 in the denominator. Click the right arrow to get out of the fraction, minus fraction, hit divide to make the fraction, 1 in the numerator, 4 in the denominator, that's 0.5. If you wanted it to be a fraction, you can just click the fraction button. You can go back and forth. We've got 1/2 or 0.5. I know we like decimals sometimes, so I'll keep it at 0.5. At least in really, when we compare them with fractions, we like decimals better. So 0.5, and I'll call that b. And then on the other side, when you type in -15 plus 45, you get 30. From here, we divide both sides by the coefficient. Well, the coefficient is 0.5. That means we have 1b equals 30/2 is 60. Essentially, this is saying how many 50-cent groups can I make out of $30? Because every $1 has two 50-cent groups, $30 has 60 50-cent groups. Last number 4, we're going to split. Label, I'll put these on the left, plain numbers on the right. And then now we distribute if we can, which we can. We have parentheses with a number on the outside. So I'm doing 1/2 times 4. Well, 1/2 times 4 is 2. So this is 1/2 times 4b, or 2 b's. Then I have 1/2 times 6, which is 3. That was a positive. Okay, then I'm copying the other side down, negative 5b plus 24, just so I can stay organized. Sorting the terms, 2b stays on the b side, keep the sign the same. Plus 3 switches sides to the plain numbers, switch signs to negative 3b. Negative 5b has to switch to the b side, change signs, positive 5b. Plus 24 is on the number side, so it stays. Keep the same sign, positive 24. This is where we type. 2b's plus 5b's is 7b's. Negative 3 plus 24 is positive 21. And then now we divide by the coefficient, which is 7. 7 over 7 is 1, so we have 1b. 21 over 7 is 3. Then we go to 3 French hens. 3 French hens. We're asked to. This part was just to help you. That's not actually going to be on a test. On a test, you'd have just this question. So I know we're using rise over run because it says so here. But if I didn't have this piece, then I know I'm using rise over run because it says slope. Because it says slope, I know we need rise over run. Okay? So that means I should probably know what rise and run are. Rise is up and down. That talks about books. So I'll really have some number of books over whatever the run is. The run going sideways is time in weeks. So I will have weeks here. Well, from the story, they tell us that we have 24 books, so 24 in the numerator, and 15 weeks, so 15 in the denominator, which means the slope is 24 over 15. That's rise, run. Okay. So what we're going to do is we're going to try and find 24 rise and 15 run. 24 rise and 15 run. I know that 15 is here because that's exactly between 10 and 20. That's on the graph. However, this is not my answer. That's not my answer because this graph has a slope of 0. The slope's not 0. The slope is 24 over 15. For the same-ish reason, similar reason, I can cross out answer D. That slope is undefined, but we know our slope should be 24 over 15. So again, I'm looking for a rise of 24 over a run of 15. We're looking for, can I go up to 24 and over to 15 and fall on the line? We've got rise 24 over 15, and we see that answer choice B is on the line. Okay, looking at the next French hen problem, we've got a bottle contains 30 fluid ounces of orange juice and 18 of pineapple juice. Which graph has a slope that best represents the ratio? Again, we want slope. That's rise over run. Okay, well, the rise is the stuff that goes up and down. That's orange juice. And they told us that we had 30 ounces of orange juice. The run, X, talks about pineapple juice. And they told us that we had 18 ounces of pineapple juice. So rise over run, or orange juice over pineapple juice, is 30 over 18. So I'm looking, can I go up 30 and over 18? And these graphs don't have a 30 over 18. Because I can't find it on the graph doesn't count that high, we're going to use Desmos to simplify. So I'm going to Desmos and we're going to type in 30 over 18. 30 over 18 is 1.6 repeating, which isn't going to help me because I can't count 1.6 repeating rise and run. I need a fraction so I can count the rise and the run. So I'm going to click the fraction button to make that 5/3. Now that I have 5/3, I can count the rise over run. I'm rising 5 and running 3. 5 is between the 4 and the 8, but a lot closer to the 4. I'm going to mark that on my graphs, just easy for me to see. And 3 is exactly between 2 and 4. I just marked those on my graphs, easier for me to see. Now I'm trying to go, can I rise 5 and run 3? Rise 5, run 3, and I should fall on the graph. Rise 5, run 3, I should fall on the line. Rise 5, run 3, I should be on the line. Rise 5, run 3, I should be on the line. And the only one I appear on the line for is answer G. Now we are on 4 calling birds. This is Pythagorean theorem. You have questions similar to this on your test. Number 1 says, one leg of a right triangle is 15 inches long. The hypotenuse is 25 inches long. How long is the other leg? This talks to me about a right triangle. Because I have a right triangle, I know I can use a squared plus b squared equals c squared. Then they further tell me we've got one leg is 15. So I can say instead of b, we'll use 15. I'm gonna erase b actually and just put 15. That didn't work like I wanted it to. Got 15 squared now. Okay, and then it tells me that the hypotenuse is 25. So I'm going to erase C and put 25. After this, I'm looking for a leg, so I have to minus. If you know what C is, you have to minus. So we're typing in 25 squared minus 15 squared to get A squared. 25 squared minus 15 squared. We've got 25 to square it. We're clicking A squared minus 15 squared. You could type A to the B, but then you have to type your own exponent. When you do 25 squared minus 15 squared, you get 400. So we have 400 equals A squared. However, we weren't asked for the square of the leg. Instead, we were asked for just the leg. So I don't want squared. To get rid of squared, you square root the other side, which means that just the leg A is whatever the square root of 400 is. And we type that in. The square root of 400 is 20. I'm not going to do the rest of the calculator work here. I'm just going to give the answers, but you guys know how you could type them in. Number 2 wants me to find the missing side of a right triangle. I know for 2 reasons that this is a right triangle. 1, it says in the words, and 2, there's a right angle marking. Because I have a right triangle, we can use a squared plus b squared equals c squared. They told us that a or b was 9. So I've got 9, but I still have to square it, plus b, which would be the other leg, 40. So 9 squared plus 40 squared equals c squared. Well, I don't know what c squared is. I'm just going to leave that as c squared. From here, we're typing in 9 squared plus 40 squared. I don't know what c is, so I get to add. I do know both numbers touching the plus, so I get to add. We're typing in 9 squared plus 40 squared and get 1681. That's the same as c squared. However, we weren't looking for c squared. We were looking for c. We want to get rid of square, so we do that by taking the square root. When you type in the square root of 1681, you get 41 to equal c. Number 3. We've got graph the 2 points on a coordinate grid, then use Pythagorean theorem to find the distance between the points. Round to the nearest tenth if necessary. So we're going to graph both points. I'm graphing 3, 1, 3, 1, and then I'm graphing negative 1, negative 4, negative 1, negative 4. Okay, on your test, you have a question like this where the points are already plotted, and you just have to find the distance. That's tricky, though, because this is what your problem looks like then. And a lot of us think, oh, we'll draw the right triangle and do rise over run. When you have a graph, you're doing either you're finding rise over run, you're either finding rise over run, because you want the slope. Or you're doing a squared plus b squared equals c squared because you want the length or the distance. Okay. This problem specifically asks for the distance. Because we want distance, we're using Pythagorean theorem, not slope. That means now I just count the legs, and then I can use Pythagorean theorem. I know I can use Pythagorean theorem because we have a right triangle. I can also use rise over run for right triangles, but we want distance, not slope. From here, we are counting the legs. This is 1, 2, 3, 4, 5. Leg of 5, so I'll have 5 squared plus the other leg squared. Other leg is 1, 2, 3, 4. And this is equal to c squared. From here, we can just type on our calculator. I just have to think, should I add or should I minus? We add if we know both numbers by the plus sign, which we do. We minus if we know c, which we don't. So we are adding 5 squared plus 4 squared is 41. So 41 equals c squared. However, c squared would be this area, the square coming off of the hypotenuse c. And that's not what we were asked to find. We were asked to find just the length, just how long that single line is. That is c, not c squared. So we need to get rid of square by square rooting the other side. So c is about, I believe that is 6.4 when you round to the nearest tenth. And they don't tell me how long each square is, so I'm going to say 6.4 units. And then number 4, we want to find the lengths for w and x. So I see w is right here, and that's part of a right triangle. Because it's part of a right triangle, I know I can use a squared plus b squared equals c squared. And this is to find w. Well, w touches the right angle, which means w is a leg. So I can put w in the leg. The other leg is 16. And then the hypotenuse is 20 because it's across from the right angle. From here, I have to ask, should I add or should I minus? I add if I know both signs touching the plus sign, which I don't. I minus if I know c at all, which I do. So we will type 20 squared minus 16 squared to get w squared. When we do that, we'll get 144 equals w squared. Careful reminder here, we didn't want w squared, we wanted just w. So we have to get rid of square. We do that by square rooting the other side. So 12 is equal to w after you type that in the computer. That was just for w. Now we want to find x. X is also part of a right triangle. So because it's part of a right triangle, I can use a squared plus b squared equals c squared. X is across from the right angle. So x will be the hypotenuse. I'm using x squared for the hypotenuse. And this is equal to the legs squared and added together. One of the legs is 12. I'll have 12 squared added with the other leg, 5 squared. Now I'm asking, should I add or minus? Because we know both sides, both numbers touching the plus sign, we should add. So we're typing 5 squared plus 12 squared, which is 169. That equals x squared. However, we didn't want x squared. We wanted just regular old x. So I've got to get rid of the square. And we do that by square rooting 169, the other side. Square root of 169 is 13. So x is 13. And now we're done with that. Okay. To keep this video from being super long, I'm going to cut this in half. So after we get to 6 days, then pause this and go to the next video. Number 1 on 5 gold rings. This is again a slope problem where we want to find the slope because it says that. Slope is rise over run, and then we want to match it to the graph. So all of these graphs have a rise that talks about miles. Well, in the problem, they tell us 68 miles. Now I need to divide that by the run, but the run in all of these graphs talks about minutes. And the problem says 136 minutes. So I know that the slope is 68 over 136. So I'm going to try to go up 68 over 136. Small problem, these numbers on the graph don't go up that far. So I do have to use Desmos. We go on to Desmos and we type in 68 over 136 and it gets us 0.5. Can't use decimals because I need rise and run. So I click the fraction button and that gets us 1/2. Now we're trying to go up 1 over 2 and fall on the line. Up 1 over 2, fall on the line. Up 1 over, actually I can cross out D because the slope in D is a flat line, a Z for 0. Regardless, that one didn't fall on the line anyways. 1 up, 1 right, rise, run 2 didn't fall on the line. The only one that worked for was C, so your answer is C. The slope was 1/2 or 68 miles over 136 minutes, which is 1/2. Okay. Looking at the next problem for that, 5 gold rings. This doesn't tell me that I want to find the slope, but it does say miles per minute. Miles per minute means miles over minute. And they told us in the story that we have 25 miles. And we have 30 minutes. Which means the slope, 4 miles per minute, is 25 over 30. In this case, I don't have to use Desmos to divide because these numbers do go up to 25 and 30. So 25 is between the 20 and the 30. That's rise, so I'm marking it on the y value and the y-axis. And then 30 is already marked on the x-axis nicely. So I'm trying to go rise 25, run to 30, and I should be in the line. Rise 25, run to 30. I'm looking to be on the line. And the only one that happens for is graph C. And now we are on 6, Giesa Lane. On your test, you're going to have something like this. You're going to put numbers in the boxes. It's asking for numbers in the boxes for numbers 1 and 3. For number 2, it wants symbols. Okay, so number 1. Billy saved blah, blah, blah. Sally saved blah, blah, blah. Write an inequality to represent the number of weeks in which Billy has saved less than Sally. Because Billy is saved less, Billy gets the pointy side of the inequality and Sally gets the open side, which means the left side is Billy. All of Billy's numbers have to go on the left. So Billy has 340 and saves 8 each week. Every per are your keywords for multiplying, so 8 goes by the x and 340 is by itself. Okay. And then Sally has to be the open side because we had to be less than. And Sally has 200 and saves 15 each week. So x, and then she's got 200 by herself. I'm going to do number 3 next because it's more similar to number 1 than the next one is. Sierra and Brian are collecting cans. Sierra has this many cans and gets that much each day. Brian has this many cans and collects this much each day. Write an inequality that displays the days where Brian has collected more than Sierra. So I want Brian to be more than Sierra, which means Sierra gets the pointy side and Brian gets the open side. The open side, again, is on the left, so Brian should be on the left and Sierra on the right. But when you read the problem, it talks about Sierra first. So Sierra's numbers, 340 and 5 each day, have to go on the right side. 340 by itself, 5 by the X because it says each day, so it's happening many times. And then for Brian, we've got 225 cans, and he collects 8 each day, so 8 X's. And then number 2, a rectangle shown with the dimensions in units. Line segment AB is greater than line segment AD. This tells me about the inequality right here. AB is greater than AD, which means AB has to get the open side of the inequality and AD gets the pointy side of the inequality. So the symbol should look like that. Okay. That's great. Looking here, I see 9x minus 16. So between 9x and 16, I have a minus sign. Well, this talks about AB, which should be on the open side of the inequality. The next side has 1.5x plus 42. So a plus goes between 1.5x's and 42. And that side is AD, which is on the small side of the inequality. So the symbols should look like this. Number 4 compares a tank with this many gallons and this much is leaking every hour, and a pool containing this many gallons and this much being filled up every hour. We want to write an inequality for the hours that pass when the tank contains less than the pool. To say the tank is less, the tank needs to get the pointy side, which means the pool gets the open side. So your symbol looks like this. Now I'm just going to replace T with all of the tank's numbers. Well, the tank has 1060. And 35 gallons leak every hour. Every hour is your keyword for multiplying. So this is 35x. And because it's leaking, it's minus. And then the other side is the pool. So I'm going to erase P and put all the numbers I know for the pool. It has 106 already. And it's being filled, so adding 105 every hour. And that is the inequality. Okay, so that is days 1 through 6. The next video will be days 7 through 12.